Welcome to this week's episode of Basics of Programming. This episode will be on variables, focusing on variable types and set in the context of Java. As with future episodes, this video will be divided into two sections, essential knowledge and additional information. Feel free to skip ahead to section 2 if you already know how to use variables in Java. With that out of the way, let's begin. Part 1. Essential knowledge on variables, variable types, and how to implement them in Java. First off, what is a variable? As I mentioned at the end of last week's episode, the purpose of a variable is to hold information and let the program perform operations on that information. At a base level, this means that a variable is simply a structure that lets a programmer retrieve information or change information, more commonly referred to as the operations getting and setting. The most important aspect of a variable is that it can vary, unlike constant values that you can type out in a program. In that way, you can think of programming variables as related to algebra variables, as both are used as a placeholder for a value within a specific set. For example, algebra variables can represent any real number that solves an equation. Similar to different number systems, integers, rational numbers, etc., variables can be divided into many categories of values. These categories are known as types, and most languages sort variables into specific variable types, including nearly all high-level languages. These types limit the information in each variable to specific subsets, such as integers, strings of characters, or booleans. As you can see in the image to the right, each of these variables stores a very different value based on its type. This system makes it significantly easier for a computer to translate information into a specific usable value, such as a word or number, as well as telling the program what operations a variable can be a part of. For example, by setting a variable to a string, the computer knows to interpret the memory holding that variable as a string, and knows it cannot perform numerical multiplication on that value. The most important variable types to get started with in Java are int, which is an integer value, char, which is a single character, string, double, which is a floating point integer or a number with a decimal place, and boolean. There are many other variable types, in fact infinite possible types because a programmer can create them. But they are not nearly as important as these variable types. Now that we understand variables and variable types, let's talk about how to use a variable in Java. As a disclaimer, many languages differ on how they implement variables. So while I will highlight some major differences in C languages or Python, some of this information may be invalid in other languages. In Java, variables must be first declared, then initialized, and only after initialization can the value of a variable be retrieved. Declaration is the act of creating a variable and assigning it to a type. In Python, declaration occurs in the background and as a result is not written in programs. In C languages, this step allocates memory or chooses a position in the memory to save the variable, whereas in Java, this step occurs during initialization. To declare a variable in Java or C, write the type and then the variable name. Initialization is the act of assigning a constant value, also known as a literal, to a variable. This literal can also be retrieved from the variable. As seen on the right, variable A is being set to the literal 123, and later variable C is being assigned to the value of A added to the value of B, which becomes a literal once addition finishes. As seen in that example, retrieving a variable's value is as simple as writing the variable's name where a literal could go. As seen on the last line again, writing variable A told the program to use the value of variable A, which is 123. Now I move on to part 2, additional information about variables in Java. This section will make a little sense without understanding method calls, so feel free to come back to this part later. As a major disclaimer, this section is specific to Java, and may have little application to some other languages. At this point, expect everything to be Java specific. In Java, all variables fall under one of two very distinct categories: objects, which are variable instances of classes, and primitives. Primitives can be thought of as lowest level variable types, such as int, double, or char. They do not have any methods, just built-in operations such as math equations, and exist wholly to store information. All of the important variable types I mentioned previously are primitives, with the sole exception of strings, as primitives are extremely efficient at storing information and much simpler to use. Objects, on the other hand, are much more versatile than primitives. They can be thought of as variable types that use primitives to store information in specific ways. For example, arrays are a set of values rather than a single value, which allows for more efficient programming in many cases, such as when using loops. More importantly, objects have internal methods, which allows programmers to reuse often lengthy and complex code, as well as allowing the use of operations programmers would not have access to otherwise. We will talk about methods later in this series as they are very important to programming in Java, but we need to cover some other topics first. It's easy to tell primitives and objects apart in Java in a variety of ways, but when in doubt, remember that the type of any object is capitalized, while the type of any primitive is lowercase. In Java, there is a limited set of primitive variable types, each made by the language developer, but an unlimited set of object variable types, many made by programmers. In fact, every primitive variable type has an object type that holds the same information, such as integer acting like int, character standing in for char, etc. These objects are known as wrapper classes, as they contain everything the other variable type had and added onto it. Wrapper classes exist because objects have methods and primitives do not, as we covered in the previous slide. This allows for the Java developers to add many methods to use, such as typecasting. Typecasting is the act of taking the information from a variable and changing it into another type. For example, you can take an integer variable of value 2 and typecast into a double variable, which creates a double variable of value 2. Going the other way, typecasting a double variable of value 2.5 into an integer would drop the floating point value, truncating the number to get an integer value of 2. A common example of typecasting is the toString method, and many wrapper classes such as integer, which converts the number into a string, replacing digits with the character forms of those digits. Typecasting directly can only happen between certain variables, and typecasting between a primitive and its wrapper class is done automatically and known as autoboxing or unboxing. Finally, we move on to today's last topic, pass by value versus pass by reference. Specifically in Java, all primitive variables are passed by value, while all objects are passed by reference. Pass by value means that when passing a variable into a method, the value of that variable is passed rather than its index. From the perspective of memory, the variable is copied to a new index, and the new index is passed, rather than the old index. On the other hand, pass by reference gives the memory index of the variable, meaning that any modifications to that variable in the method changes the original variable. This is very important in Java because passing an object lets you do an operation on that object in the method, getting around the need for a return statement. Since Java only allows one returned value, this is very useful when modifying multiple variables. On the other hand, if a variable must be an object and you do not want to change the original, you are forced to perform a deep copy of the variable. A shallow copy is passed by reference, creating a new variable that refers to the same memory index, while a deep copy is passed by value, moving the information to a new index and giving the variable the index of that new memory slot. Intelligent use of primitives versus objects and remembering to perform a deep copy on objects can make it significantly easier to design and use methods. And with that, today's episode comes to an end. Feel free to leave comments below. I would love to see what you thought about the episode or any feedback on the format. If you have any topics you would like to learn, please let me know below. Thank you for watching, and I hope this video helped you better understand variables and how to use them.